Hi, I'm Nicole.
I'm Daniela.
Number, problem number 9, and in order to solve it, we need our knowledge of physics and maths, and we need some formulas that are derivatives and some others that are velocity, speed, displacement, time, and acceleration. And another important fact is that also we need kinematic equations. And an important key is that we have to remember that in problems of free fall, the acceleration is minus 9.81.
We're asked to find the position function from the calculus book, and the formula is this one. We substitute the values that we already knew, and we found out that this one was the position function. Then we were asked to find the velocity function of the calculus book by using the limit definition of derivatives. This one is the formula for limit definition of derivatives. After we did all the process by substituting also the values that we already had, we found out that the velocity function of the calculus book was vt equals minus 9.8 t. Then we were asked to find the acceleration function by using differentiation rules, and this was our velocity function we derivated, and the acceleration function is a of t equals minus 9.8 meters per second squared. And here in D, we were asked to calculate the velocity of the book after 1.1 seconds. So we knew that 1.1 seconds was our time, and we substitute in our velocity function 1.1 here and here where we had our t's, and we find out that the velocity after 1.1 second was minus 10.7 meters per second. In E, we were asked what is the velocity of the book when Mike catches it at a height of 1 meter from the ground. So in the position function, we substitute 1 meter and the values that we already know, and we isolated for t squared to find time, and we found out that time was 1.96, but we were asked the velocity, so we substituted our time in the velocity function to find out that the velocity after 1.96 seconds at 1 meter was minus 19.2 meters per second. And the last one was with how much initial velocity should Peter throw the book to arrive in half time of dropping, and we just divided the time by 2 because we needed to know at half the time in the same position, 1 meter, and we isolated for initial velocity, and we found out that the initial velocity that we needed to have was minus 23.7 meters per second.
Conclusion is that derivatives are constantly used in everyday life, helping us to see how much something is changing. They help us understand how large things are made from smaller things, and kinematics explains and helps us understand how objects move. In physics, problems can help us to get the velocity or the acceleration of any object.